let's talk about how to loop through 2D arrays. Just like arrays and just like array lists, you don't really start to see the power of these until you start looping through them. That's kind of the whole point is, hey, let's do this thing for everything that's stored in here. So let's talk about how to do this real quick. So hopefully this looks very familiar, okay? This is basically saying I'm going to loop through everything in the matrix, okay? But remember, the contents of your 2D array is other arrays. So this is saying I'm going to loop through every array in my array. Now you'll notice I've used R instead of A. Well, why is that? Well, because every array in my 2D array is a row. So this is basically saying that I'm going to start on row 0 and I'm going to keep going until I've hit all of my rows. Okay, well once you've hit a row, how do you hit every single element in that row? Well, now I'm going to have to loop through that individual array, okay? And I'm going to have to look at every column within that row. So what I do is I do a nested for loop here. I do a loop within there. And you'll notice I use C because I'm talking about columns. Now the question is, how far do I need to go? Well, I need to go as far as the length of my row. So think about it like the length of the original matrix is just how many matrices are inside, how many rows there are, okay? But the columns is the length of one of those rows. So, so what I do is I say, I'm going to grab the row that I'm on. So that's this guy. And then I'm going to do the length of that row. Okay, and that's going to tell me how many columns that I have. Now, if you want, you can do 0 here and just say, well, whatever the length of the first row is. We're going to do that every time. The only time that's going to bite you in the butt is there are 2D arrays where each row is actually a different length. It's not terribly common, but if you have something like that, then you have to um, each time you loop through, you have to change the length of your row or you're going to go out of bounds, okay? So let's back up. Loop through every row by using the length of the matrix. Loop through every column by using the length of one of your rows, or again, we can make sure that that length changes by using the length of the specific row that we're on. Okay, so now what do I do? Well, now we have this row value that we've saved as R. We have this column value that we've saved with C. So now we just access that location within our matrix, okay? That specific row, that specific column, all right? So I could print out everything. I could change all of the values. I could try to detect something within my matrix, but it's all going to be referencing these individual elements. Now, what this does is it loops through it in something called row major order. So you do first row, then the second row, then the third row. Now, there are other times where you want to loop in column major order. So you do the first column, then the second column, then the third column. So this is called looping through in column major order. And the way that you do that is actually real simple. You just reverse the order. You just say, well, first I'm going to loop through the columns, then I'm going to loop through the rows. And really nothing else changes. You still are referencing RC as long as you named it R and C, which you did, right? Okay. Now, one thing to say about this, looping through row major order still works pretty well, even if the rows are different sizes. Looping in column major order that way is a little gross. I'm sure there's a way to do it. but it's not as simple as looping through row major order is when the rows are different sizes. So let's take a look here. So if I wanted to loop through num matrix here, okay, I just loop through every row, I loop through every column, and then I'm printing out each element here. So 1, 2, 3, 4, okay, that first row, 5, 6, 7, 8, 9, 10, 11, 12. So it's in the order that they appear row-wise. But column major order, I'm looping through columns first, then rows. So I'm doing 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. And that's what we've got down here. Okay, so this is what you're going to mostly be doing with these 2D arrays is, looping through them, doing different stuff. There's also situations where you're just kind of trying to treat something as a grid and move around in that grid. But a lot of times you're going to need these loops to get the job done.